Hello, my dear children. This is P. Venkateshwarlu, PGT Physics. So, according to yesterday topic, at last we have discussed about angular momentum. Okay, angular momentum and conservation of angular momentum in a chapter 7 plus 1 NCERT system of particles and rotational motion. So now I am going to discuss about equilibrium of a rigid body. Equilibrium of a rigid body. What is the content, my children? Equilibrium of a rigid body. Equilibrium of a rigid body. Equilibrium itself, equal means doesn't change. Equal or doesn't change of a rigid body. Okay, so what is rigid body, my children? So rigid body is a body having particular shape and size. So in that there is no change in the distance between all points if the point of application of force. Okay, that is called rigid body. Rigid body is not different body. Okay, it is a solid body. Rigid body is said to be a body having particular shape and size in which the distance between two particles will not change even though we have to apply force. That we can say rigid body. Okay, here we can have 2 points. Okay, first one is, so when a body is said to be equilibrium means the total force acting on the body is 0 or the net torque acting on the body is 0. Okay, so when a body is said to be equilibrium means in this system of particles the total force or net force acting on the body is 0 or net torque acting on the body is 0. Okay, so at that time we can say equilibrium of a rigid body. Equilibrium of a rigid body. Okay, so no translational motion. And no rotational motion. Rotational motion. Understand? Okay. So first, if net the total force acting on the body is 0. 0 means F1 plus F2 plus F3 and so on plus Fn sigma I is equal to n sigma I is equal to 1 to n F5. Okay, according to this sigma I is equal to 1 to n Fi is equal to 0 means no linear acceleration and no linear motion or no translational motion. So next one, what, my children? The total torque acting on the body is 0. The total torque acting on the body is 0. Means what is the total torque? Total torque is equal to 0. Means tau 1 plus tau 2 plus tau 3 plus and so on tau n, which is equal to sigma I is equal to 1 to n tau n. Okay, according to this condition, sigma I is equal to 1 to n, tau n is equal to 0. Tau I. Okay, understand? So this is about equilibrium of a rigid body. Equilibrium of a rigid body means net torque and net force acting on the body is zero. Okay, in this case we can have no angular acceleration, no linear acceleration. Means everything will zero. Alpha is equal to 0, a is equal to 0. Okay, so we can say this no motion, no different types of motion. So whether it is which is in uniform circular motion or uniform motion, there is no change. Okay, understand? So coming to rotational equilibrium only. Next one. Rotational equilibrium. Rotational equilibrium only. Okay, see here, when a body is said to be rotational equilibrium means the net torque, only net torque acting on the body is zero. We can say the body is said to be rotational equilibrium. Okay, means net torque is equal to 0, but net force is not equal to 0. Okay, understand? Force is non-zero. So then angular acceleration is 0. Angular acceleration is 0. Here non-zero linear acceleration. Non-zero linear acceleration. So consider a body. Okay, understand? Here two forces are acting. Say F1 and F2. Okay, see here net torque acting on the body is 0. Net torque is 0, but net force is not equal to 0. Net force not equal to 0, my children. Okay, understand? See here P and Q. Okay, so in this case consider a center, it is denoted O. Okay, in this case net force is not equal to 0, but net torque is 0. Understand, my children? Net torque acting on the body is 0 because we can say clockwise tau negative and anti-clockwise torque positive. We have to take like this, my children. Okay, we have to take like this means it is perpendicular distance. It is perpendicular distance R and R. Same force we can apply. Same force. What happened we can see clockwise. So we know that clock means the needle of the second. Okay, like this. This is clockwise. Understand? Here we can say this is positive. This is negative. So how we can get this means? Okay, how net torque will 0 means what is this clockwise? Clockwise torque means F into R minus anti-clockwise. This is anti-clockwise. So clockwise direction, this is opposite. Plus Fr is equal to what? 0. We can get torque value is 0 in this case. Understand? So while the body moves down. Okay, so means non-zero linear acceleration, it may fall down. Okay, not rotation. In rotational equilibrium, there is no angular motion. Only we can get linear motion or linear acceleration. Okay, so next translational equilibrium. Translational equilibrium only. Translational. Translational equilibrium only. Translational means what, my children? Okay, translation means consider a body, the body moves from A to B. Okay, so in this case consider center and another three particles like this. Okay, see here, in this case the center point will move in a straight line. Okay, understand? So each and every point of a object which is in linear motion, we can say that is translational motion. Okay, understand? So another example, consider a cube, 1, 2, 3 points. Okay, A, consider point B, same points. Okay, see here, we can move this body like this. Okay, which is in motion. Okay, in this case every point will execute linear motion. We can say this type of motion is translational motion. Translational equilibrium only. So when a body is said to be which is in translational equilibrium, see here, first one, net force is equal to 0. Okay, net force is equal to 0 means no acceleration, no linear acceleration, but non-zero net force. Okay, see, tau net is not equal to 0. Okay, only angular acceleration, the body which is in angular acceleration, it is denoted alpha. Okay, the rate of change of angular velocity is called angular acceleration. Okay, understand? So in this case we can say the body which is in rotational motion, my children. Okay, see, consider point O, here A, here B. In this case, one force is acting downward, another force is acting upward. Okay, in this case net torque will not zero, and net force is acting 0. How we can get net force 0? How we can get? See here, this is positive. If force moves upward, this is positive. If force downward, negative. How we can get 0? F, this is x plus minus f. That's why 0. Okay. So whenever net force is acting on the particular body is 0, in this case the body which is in rotational, which executes angular acceleration. Means the body is rotating like this, anti-clockwise like this. Understand? So here translational equilibrium means net force acting on the body 0, but net torque will not 0. Means no linear acceleration. There is no linear motion. Only angular motion is there, rotating. Okay, understand my children? Next, principle of moment. Principle of moment. Principle of moment. Okay, so when a body which is in rotational equilibrium, okay, so rotational equilibrium. When a body rotational equilibrium on a sharp object, okay, consider a one bar which lies on a sharp object. You can say the object is said to be pivoted. Understand my children? Understand? So when the rod which is in rotational equilibrium on a particular point, okay, see here, this is R, you can say fulcrum, okay, see here, we can apply some force here, see here, the force is moves in opposite direction, okay, so we can say this is effort, and effort RE, and here load, okay, and here RM. This is fulcrum in which the body which is its may oscillate, move up and down, opposite. Okay, understand? In this case, what manner? In rotational motion or rotational equilibrium, what is the condition? Net torque is zero. Understand? So net torque means what? My dear children? Okay. What is the torque here? This is clockwise direction. This is clockwise direction. This is anti-clockwise direction. Okay. Clockwise and anti-clockwise, we have to take both. We have to take that value of positive or negative. Positive or negative, my dear children. Positive or negative. Okay. Understand, my dear children? Okay. So like this, how we have to get. Understand? See here. So net torque means zero means what? This is clockwise, negative. This is anti-clockwise, opposite. Okay, opposite. This is positive. Okay. So we have to find total torque. Here torque is what? Force into perpendicular distance. E is the force and perpendicular distance RE. Okay, so this is negative. Plus here opposite direction, force L, perpendicular distance RL. Understand? Which is equal to 0. Understand? So rearrange this, you can get L RL is equal to ERE. Okay. So here the terms here L means, sorry, here E means effort. E means effort, my children. So effort means indirectly force. So how we can define effort means how much amount of force acting on the body a person is applied. Okay. So the force which is applied by the person, we can say effort. Okay. RE, effort arm. This is from the midpoint of this effort arm. Okay. So we can say L, load. Okay. Understand? So what is load, my children? Okay. So load is the force. Load is the force due to the effort. Okay. So if effort can apply the person, so the force is converted into load. Okay. Load may changes the body one place to another place. Okay. Next, RL, load arm. Okay. Understand? So what is this condition? Load into load arm is equal to effort into effort arm. Okay, it is visible, yes. Okay, load into load arm, effort into effort arm is called principle of moment. Okay, principle of moment. Understand, my children? Yes. See here, load into load arm is equal to effort into effort arm is called this equation, which gives the principle of moment. Principle of moment, my children. Okay, so this we can say principle of moment. Okay, my children. So from this we have to write what we can write? L by E, load by effort is equal to load by effort is equal to effort arm by load arm. Okay, understand, my children? So in this case, we can say the load is F2. It is indicate F2 into D2. Here F1 into D1. Okay, understand? See here, F1, D1, F2, D2, like that. So we have to write F2 by F1 is equal to D2 by D1. Okay, so we can say load by effort, we can say mechanical advantage, my children. See here, this is the equation, we can say this is mechanical advantage. Mechanical advantage MA is equal to F2 by F1, that is equal to D2 by D1. Means load by effort is equal to effort arm by effort arm. Okay, understand? Load arm by effort arm. Here 2, 1. Okay, understand, my children? So mechanical advantage, which is defined as output value by input value, we can say efficiency of mechanical advantage. Okay, see here, my children. See, whenever we can displace the heavy object, so with the help of lever. So by using the principle of moment. Okay, how we can say? Okay, see here, we can have one heavy object. Okay, so how we can displace? Okay, we are applying force, the body will not move. Okay, so with the help of a small stone, so we can keep one big lever. Okay, understand? So here we can apply effort, means we can apply force, we can say effort. So up to this we can have that is effort means F1. Okay, here the distance is D1, effort arm. Here load is applied, load means F2. Okay, here in this case this we can say D2. So we are applying force, means the body displaces. Okay, understand? So this is heavier object. Even though by the application of less force, the body will move. Okay, so like this we are observing in so many cases how the body displaces in villages especially. So by using one wood lever. Okay, we can take one wood lever, so we can apply force. Okay, by using principle of momentum, the body will move. Okay, so they have no idea about this principle of moment, but indirectly they are applied force, okay, by the changing of position of heavier object. Okay, my dear children.